This next section is a bonus section, and it wasn't included in your book, but I find it's really helpful. So I've been saying this entire time that a had to be greater than 1. It couldn't be negative, right? The base of our logarithm couldn't be 0, 1, or negative. So we're going to talk about why that is. We're also going to talk about why you can't take the log of 0 or of negative numbers. So this is a little bonus section I hope you enjoy. I had fun putting it together. So let's remember that y equals log base a of x is equivalent to x equals a to the y. If we had a base 0, like we're trying to show why the base can't be 0, let's start with that case. If I had a base 0, then log base 0 of 2 equals a would imply 0 to some number equals 2. And that can't be true because you can't raise 0 to a power and get something other than 0. And 0 to the 0, in case that was your next question, is undefined. Well, what if we had base 1? That would mean if I had log base 1 of 2 and I got some number out, would imply that 1 to some power would give me 2. And that's not true because 1 to any power is always going to be 1. So that's why we can't have a base of a logarithm that's 1. What if I had a negative? So let's say I had log base negative 2 of x would equal 1/2. That would mean negative 2 to the 1/2 is x. So the square root of negative 2 is x, and that's a complex number, right? So that's why our base has to be greater than 1 because it can't be 0, it can't be 1, and it can't be negative. So while the value of a logarithm itself can be 0, positive or negative, right? Negative numbers and 0 aren't acceptable arguments to plug into a logarithm. Let's look at the log of 0, right? If I have log base 2 of 0 equals b, that means 2 to b gives me something, and we can't have something give me nothing. So that's why we could never take a logarithm of 0. We did show earlier that logarithms can only have positive bases, right? Because a positive number raised to any power is positive, right? A positive number raised to any power is always positive, even if it's a negative exponent. So that's why the argument in our logarithm can never be negative. It has to be positive. So logarithms of negative numbers are undefined, and I'm glad you asked why. So we're going to go through an example to show us why they'd be undefined, other than the fact that you get complex numbers. So let's talk about why the solution of this equation would only be 27. So first let's use the quotient rule, not quotient, power. I have log base 3 of x times x minus 24 equals 4. So I have log base 3 of x squared minus 24x equals 4. And let's convert this to an exponent. So I have x squared minus 24 equals 3 to the 4th, which is 81. X squared minus 24 minus 81, equals 0. Now I can solve this. I can say, okay, what are some factors of 81 that add up to negative 24? And that's going to be negative 27 and positive 3. So I have that x equals 27 or x equals negative 3. But because we cannot take the logarithm of a negative number, right, our only possible solution to this equation would be x equals 27. I hope this helped clarify some things about logarithms of 0, 1, and negative numbers.